Hello everyone, and welcome to the webinar on deploying ML models with Azure and Flask. My name is Srujan Deshpande, and along with Manikya Bardhan, we'll be taking you on a couple of ways that you can deploy your ML model with Azure and make it public to the world. Now, this webinar is being conducted as part of the inGenius webinar series. inGenius is India's premier hackathon and it's being conducted by PS University Electronic City campus. Our partner for today is Amigos. Amigos is the student social network. And pay attention to the webinar because we'll be having a quiz on the Amigos app where you can get a chance to win up to 1,000 rupees at 6:45 right after the webinar. So without much further ado, let's get started. All right. So what are we going to do today? What are you going to learn in this webinar? So over the course of whatever project you build, you might make a very nice model. You'll put all your heart and soul and effort into it. But now you've got to make that model public to the world. So that's what we're going to teach you. How do you export this model? How do you put it on a Flask backend? How to deploy it on an Azure VM instance? And how to deploy it on a container instance. We're showing you multiple ways of deploying this model. So you have an option. You can choose which one's easier for you and which one works better for you.
All right. So in this webinar, we'll be covering mainly about deployment part, as Srujan talked before. And you guys must have seen the 25th webinar on training your model, creating a model. So this webinar picks right from there. So in this, we'll be seeing what to do after you have your models ready in your Jupyter notebooks. So you can't really use those models in your applications, right? So we'll be learning all that in this webinar. So first of all, we'll need to export our models. There are various ways to do that. It depends on the library which you're using to create it. So as you can see here, we have a few popular libraries and methods to export your models. So PyTorch, FastAI, and TensorFlow are here. It's pretty easy. And once you have your model, you can follow along with us as well. Machine learning interoperability. So ONNX, or Open Neural Network Exchange, was created by Microsoft and Facebook back in 2017. So what this allows you to do is really, what it allows you to do is export your models from one framework to another. So say you have a model in PyTorch and you want to use TensorFlow for inference and to deploy it. So what would you have to do in this case? You can't just retrain your model in TensorFlow, right? Because it would take days and a lot of wasted resources. So ONNX comes into picture over here. So what you can do is you can convert your PyTorch model to ONNX and then use ONNX to convert to a TensorFlow model. And using that, you can just use TensorFlow for inference. So ONNX allows all these things to be done. It also has an inference backend, which allows very efficient inference. All right, let's go over to the next slide. So in this webinar, the model which we are using is for classifying an image as grizzly bear, black bear, or teddy bear. It has been fine-tuned on 150 images of each of those classes, and it was originally trained on the ImageNet dataset. It is based on the ResNet 18 architecture. Right. So Srujan will tell about why we are actually deploying on cloud. So should you like to take over?
So as I mentioned before, you've put a lot of effort into developing your application or your model. But why should you take even more effort to actually deploy it on the cloud? Well, there are a couple of reasons for that, and some of them are more important than the others. And the main one right now is it's easy to collaborate when remote working. As we all know, with the situation going around right now, your team members may be thousands of kilometers away in their hometowns. And how do you work together? If you're working on a very diverse team, some people might be working on the model, some people might be working on an application, some people might be working on a website. How do you ensure that the data is easily flowing between all three of them so that the app guys don't have to set up another backend again? And that's where the cloud comes in. If you deploy your model on the cloud, you can just set up the server on the cloud. And as you push updates to it, it'll keep getting updated. And wherever these app developers or website developers are, they can use that and not have to replicate exactly what you're doing every single time. It makes it very easy to collaborate that way. Next, we've got easy to demonstrate. It's very likely that you'll be building something like this for a hackathon, something like inGenius, and you want an easy way of showing it to your judges. Instead of showing maybe a screen recorded video of just your local model running, You can maybe generate a URL and just toss the URL and run. Say, hey, I've got this URL. You can test out my model and what we built over here. And that in itself adds a whole bit of oomph to your presentation. So it's very easy to demonstrate. It's easy to scale. So once you take your model to production, you want to make sure that it can handle the barrage of requests that are going to come in, because your model is amazing and you know people are going to use it. So how do you handle that? Well, using the cloud is very easy because you can scale up and scale down how many resources your model is using. If your model is very resource intensive, then you can use a lot of compute resources. Say people aren't requesting a model at night, you can scale it down so that it doesn't cost you that much money. And to summarize it all, we can expose this model to websites, mobile apps, and third-party developers. So if your team is working on a parallel website or mobile application, having the model on the cloud makes it very easy to communicate, and both of them can use the same backend. And for third-party developers and users, you can see some people like Google and Bing, they expose their APIs for others to use. If you've got an amazing good model and you want to do that, you can do that very easily by deploying this model on the cloud. And as the heading of this webinar mentions, we're going to use Azure to deploy. Now, there are many different cloud service providers. There's AWS, there's Azure, there's GCP, there's Heroku, and all of them work amazing. Why we're simply choosing Azure is because Azure gives a $200 credits free for students. So if you want to get started with deploying your own model, it's a great starting point to work with. And the range of products they have is pretty cool, and we'll be going into some of these products in this webinar. Now, let's start by creating a Flask server to run with the model. Now, why do we even need server in the first place? Well, basically, the model in this case is a binary file, and it has no way of communicating to the outside world. We write this Flask server so that it can communicate with the model and then communicate with whoever is requesting data from it. And it makes it easy to use. And why are we using Flask? There are many different types of backend server technologies. Why we're using Flask is because it's very, very simple to learn. You can learn Flask in as low as like 5 minutes. That's all. It's extensible, it's easy to deploy, and it's just amazingly simple. So let's dive right into how Flask works. Now, I could show you a presentation, but I think it's a lot better to just go with the code. So let's do that. Over here, I've got a Hello World app in Flask written already. Now you can see that it's only like 8 lines of code and it's not very complicated at all. And if you see, we're just importing Flask, creating an application, and creating a route. Now, if you aren't familiar with how backend and URLs work, you might ask, what is this route? Well, basically, if we have a URL such as, I don't know, www.google.com, you see that slash we put at the end? That slash means it's the base route. Then we can also do something like maybe search or, search for images. So again, this is a very hypothetical situation, but all these slashes, the slash and what you add after that is called the route. And using a backend server like this, we can define our custom routes. So if our website is hosted at a particular IP address, let's say XYZ, if someone goes to xyz.com, they're going to see hello world. Now, coming up, we can make it such that if they go to xyz.com/API, maybe, they can see some other API that we've exposed. And that makes it very convenient and very extensible for the users. Now, here we've got a simple hello world application. That's the backbone of the computer science community. You can see on the slash. So slash means there's nothing after the URL, and we're just returning a hello world. Now, how do you actually run this application? If you've got a Flask application, you've got to import Flask. And if you want to run it, the only command that you've got to do is Flask run. All right, one sec. So if you want to go through any of the code we have and we're showing in this webinar, we've put it all into a centralized GitHub repository, and we'll be showing a link for that GitHub repository soon. As I mentioned, if you just type Flask run, give it a second, and the server will just start up and we can see our requests. You can see running on port 5000. Now, if we go and maybe curl it, localhost 5000, you can see hello world. And our server works. It's as simple as that. Now, well, we're not here to teach you simple Flask servers. We're here to teach you how it works with the ML backend. Let's do that right now. So as Manikya mentioned before, this ML model works using PyTorch. And I think while I'm getting the code in, Manikya, you can tell us a little bit about how this model works and how these functions work.
Right. So basically, what we'll be doing is giving an input to our machine learning model. And given that input, our model will try to predict if that image is of a grizzly bear, black bear, or a teddy bear. So, so the input which we are actually giving is a URL, and our backend downloads that image, it saves it, and then it sends that temporary image to our model to predict. The model returns us the class of the bear, which could be grizzly, black, or teddy. And then it also gives us a percentage value as well, which basically tells us what is the percentage of the bear being a black bear, percentage of it being a teddy bear or a grizzly bear. And that will be showing in the front end itself.
All right. So that sounds pretty cool. So right here, we've written a small function to work with this backend. As you can see, if you're familiar with Python, it's called a search by URL function. And the only parameter it takes is the URL. So how we've written this demo application is it takes the URL, it downloads the picture from that URL, and then returns 4 values, which is what type of bear it is, and what is the percentage of it being each one of those type of bears. And you can see that that small function is written right here. Again, this code will be available on GitHub if you want to go through it. The model comes in the form of a pickle file, and here we've got the pre-trained model. We'll be providing a link to the model as well in case you want to try this on your own. So as you can see, I've added the function and I've added the model, and that's all we've got. That's all this is. So now what we've got to do is we've got to make a route so that people can hit that route. They can put that URL into the search bar and they can get the results from this model. And we're going to do that right now. So I'm going to call this route /API/URL/bear. So whenever someone goes to this using a post request, so there are many different types of HTTP requests, and we're going to use post for this one. They have to send some data in the form of a JSON, and this JSON will be just the URL. Once they send the data, we're going to call this function that we wrote previously, which is going to download the image, use it to infer the data, and then get the final results back out again. And then we're going to return these final results back to the user. Now, before we actually run this model, and as you can see, it's very, very small. We're less than 30 lines of code. There's one small thing that we want to fix, and that's called CORS. CORS stands for Cross-Origin Resource Sharing. And I won't go into exactly what it is. It's a little irritating, but basically what it does is that your browser wants to keep you safe and wants to make sure that data isn't randomly sent from any server to your website. So only servers would say that, hey, yes, I want to allow data going here. They can do that. So you can research more about that, but all we've done here is we've added something called Flask CORS, which allows CORS to happen. So now you can have your backend server running anywhere in the world, and you can put it into any website, and it's going to work beautifully. So how do we test this out, you ask? Well, it's very simple. We go back to our terminal, we hit Flask run, and you can see the server starting right up. If you've got a keen eye, you can notice that the server is giving us a very, very stern warning saying, this is a development server, do not use it in a production environment. And we'll get into that soon. Yes, Flask is a dev server. We won't use it in production. We'll use a different server called a WSGI server. WSGIs are known as Web Server Gateway Interface servers, and they're used for actual production web servers. The server we'll be using in this case is gUnicorn, but there are many other alternatives such as Nginx Unit and UWSGI. Once we get this line, you can see that, all right, this is running. Now, how do we test it out? Let's head to Postman and test it out. So Postman is a very nice tool that you can use for testing out your servers. In this case, I'm going to put the localhost 5000 /API/URL/bear. And I'm going to put the response. I'm going to give the URL as a picture that I got from Wikipedia. So this is just a picture. If you want a second to show you that picture. This is the picture we'll be using. It's a picture of a grizzly bear. If we go and send that request, it's taking a minute. If you go to the body, you can see that our prediction is returned. As I mentioned, it's returning 4 values, a grizzly. We've got the percentage values. So it's the first one's black bear. It's probably not a black bear. 99.9% it's a grizzly bear. And this is even lesser of it being a teddy bear. So I think that's all we've got in terms of the Flask application. As you can see, it's very, very simple. And it's very easy to learn. So you can focus more on making your ML model amazing and not have to worry about how to develop the server. If you want to see the code, you can head to the GitHub repository. It's at github.com/Srujan Deshpande/deploy/ML app. Or you can just scan this QR code and it'll take you straight there. Just pause for a second. Radio. So as I mentioned before, if you want to test this model locally, all you have to do is install the dependencies. And you can do that with pip install -r requirements.txt. You can get the model from this file, from this URL. This is tinyurl.com/bears-model. Or you can scan this QR code to redirect you to the model page as well. So this is the model that we have trained, and it just gets the bears images. Again, running the backend locally, you can just do something as simple as Flask run. Now, in the GitHub repository, you'll also see a React frontend. So we've used that frontend just so it's easier to visualize how the data is coming from the backend. And if you want to test that out as well, you can install the dependencies using npmi and run it using npm start. Now, ladies and gentlemen, it's time to jump to the cloud. And as some very wise words say, there is no cloud. It's simply someone else's computer. So as we mentioned earlier, there are a couple of ways that you can do this. You can deploy your model and your now Flask server on the cloud. And the easiest and the most straightforward way to do this is using a virtual machine. So what is a virtual machine? It's quite literally, it's a virtual computer sitting inside a physical computer in a data center. The pros of having a virtual machine is it's simple. It's ridiculously simple to set up. You click a couple of buttons and the machine's all yours. It's the most flexible. You can choose any size you want. You can choose the number of RAM, the amount of storage. You can choose if you want a compute-oriented or a memory-oriented. And it's super easy to work with. And you get access to SSH, which is a secure shell if you're using Linux. And you get access to remote desktop protocol if you get a Windows virtual machine. Now, another amazing pro of using a virtual machine is you can deploy multiple services on the same machine. So say you've got this Flask backend, you can run the backend on the virtual machine. You can run maybe a web server on the virtual machine. If you've got multiple models, you can run multiple models on the virtual machine. It's very extensible. And it's very flexible for how you want to do it. And usually a virtual machine can be the lowest cost simply because you're doing a lot more work than the cloud service provider is doing for you. Then that's compared to some of the other alternatives. But yeah, I think we'll show you how a virtual machine works. So here we've got the infrastructure diagram. As you can see, we've got Azure, which is our cloud service provider in this case. And we're running a virtual machine inside of Azure, which is running the Flask server. As you can see, our user, when they want to request something, they go directly to the Flask server and they get their data. Now, creating a virtual machine is super simple. And how do we do that? Just head to portal.azure.com. So portal.azure.com is the Azure homepage. And once you open it up, you can see all these different icons. Each one of these is a different Azure product. And we'll be using a couple of them. So the first one we're going to use is virtual machines. If you click on virtual machines, we'll go straight to the virtual machine dashboard. If you've got any virtual machines run, you can see them here. I have a couple, but you may not, that's fine. Here, if you click on the add button, you can create a new virtual machine. Now, one thing to note is that we're using a machine learning model, and if you're familiar with machine learning, they are not low on the resources. They are pretty compute intensive. So we've done a bit of experimentation, and we've decided that this virtual machine works best on a minimum. This model works best on a minimum of 2 virtual CPUs and 8 GB RAM. So that's what we're going to use. Here you can see a resource group. A resource group is basically how you organize your different machines and products. We're going to give it a name. So let's call it deploy ML model 1. I can choose a region. I'm going to choose East US 2. And then we can choose the image. I like going with Ubuntu since it's really simple. And we can choose the size. As I mentioned, there are lots of different sizes that a cloud service provider is going to give us, but we're going to stick with 2 virtual CPUs and 8 GB RAM. And for the connection method, you can also set a password or an SSH key. I'm going to use a key stored in Azure, and we'll just set that up. So there are lots of different options that Azure gives us. We can set up networking, we can set up management. It's very flexible, but I think we'll just jump straight in and create the virtual machine. Now, while the machine's being created, let's go back to our presentation and see what we've got next. Yes. So once your virtual machine gets created, you want to SSH into it. And what we mean by SSH is, let me just show you that. So SSH stands for Secure Shell, and basically, you know how you have a terminal on your computer, you can have a terminal of your virtual machine. So here I've got the command SSH, this is the private key which we're using, and this is the IP address of the virtual machine which I've created. Once I do this, I'm inside the virtual machine. Now there are a couple of commands that we need to do to actually set up this backend. And the commands that we use are, the virtual machine doesn't come with pip3 installed, and we want pip3. So we're going to install that using these commands. And we're going to just clone the repository which I've already made. And we'll go into the backend folder, we'll install the requirements using pip install -r requirements.txt and run the server using Flask run. Now the dependencies do take a bit of time to install, so that's why we've got a machine with all of them set up already. As you can see, if I navigate to the virtual machine, you can see I've got all my code here. And if I just do Flask run, you can see Flask starts up. Now, again, it very helpfully says this is a development server. Do not use it in a production environment. And yeah, we probably shouldn't do that. So in a production environment, we're going to use something called Unicorn. And Unicorn is already included in the requirements.txt file. You don't have to add anything extra. All you have to do for that is, all right, 1 second. So all we're doing for Unicorn is we're telling it to bind. What bind means is that we're telling it to go to every single IP address. It can be localhost, it can be the external IP address, the internal IP address. We want our model to be visible everywhere. So we're telling the Unicorn to go on all IP addresses. We're giving it a particular port, in this case 8000. And now if your model is resource intensive or it takes a lot of time, if someone sends a request, you don't want it to be held up on just that one request, which is why Unicorn gives us the ability to set up the number of workers and number of threads. So in this case, I put one worker in 8 threads, but you can optimize this to your machine size and how much time your model takes and how much load you're expecting. And if you remove these, it'll run on one worker, one thread, which is pretty simple as well. And once we do that, we can see Unicorn has started right up. It's listening on all ports. It's listening on all IP addresses for port 8000. And if we want to test this out, that's pretty simple actually. Let's just copy the IP address, postman, and instead of localhost, now we can just put the IP address of our virtual machine. Do that. Just send the request. And you can see now that instead of our local machine giving the answer, the virtual machine is giving the answer. And since the image is the same, you can see the answer is the same, Grizzly. But that's pretty much how it goes. And you can see it's very, very simple. It's basically your own machine on the internet. You can run anything you want on it, and it's very flexible. Now, if we dive back in, all right, let's talk about the cons of the virtual machine. So it was very easy to set up, but I think you might have noticed that the dependencies take a lot of time to install. So when we're using heavy dependencies like PyTorch and FastAI, they do take some time to install. And as I mentioned earlier, they need some RAM as well. So this PyTorch especially won't work on a machine with lower than 8 GB RAM is what we've experienced. So you're going to need a bigger machine to actually run it. And then it also takes a lot of debugging. And another problem we have is it's not flexible or easily replicable. So what I mean by that is if you create a virtual machine, you're going to have to do a lot of steps over there. And unless you write down those steps individually and then do it in another virtual machine, it's pretty hard to actually just, it would be easier to just click a button and everything gets ready for you. And we all love automation, right? Clicking a button gets ready. I think we can go right into that next. And that brings us to containers. So we won't go too deep into containers, but what containers basically are is they are a way of running an application without the guest operating system. So in a virtual machine, you have an operating system, and then you have another one inside, which is yours. But over here, we remove that second operating system layer altogether, and we run the apps directly on this platform called Docker. So this is what Docker is. Instead of a virtual machine, we're just going to use a Docker container. Now, what is a Docker container? It's basically a standard unit of software. It packages up all the code and all the dependencies reliably in just one container. So if we have a Docker image, I can just give that image to Manikya. He can run it on his computer. I can use that image to run the same thing on my computer, and I can use that image to run the same code on the cloud as well. It's lightweight, standalone, executes, and execute the software properly. So we can see that every time we run the container, the output is going to be exactly the same. All the code, the runtime, the system tools, library settings, everything is going to be packaged together. And let's look into how we can use a container. So I've made a container already for this application, and if you want, you can download it from Docker Hub. What Docker Hub is, it's how we use GitHub for pushing code. You can use Docker Hub for pushing these container images. And if you'd like to download the image and work with it directly, you can check it out using this URL or scan the QR code right here. Now, how do we create the container? So let's see. When you're creating the container, you need to use something called a Docker file. Let me pull up that Docker file right here. So you can think of containers as something like building blocks. You use one block and then you can put another one on top of it and another one on top of it until you reach your desired height. And that's what we're using here. If you want to start from the basics, you can use a container which has only, let's say, Ubuntu, or you can use another distro of Linux such as Arch Linux or Alpine Linux. But in this case, since we're using FastAI, I'm using the image that FastAI has given us. And once we do, we just do a bit of minor setup. And FastAI sets up mini conda for us. So we're going to use conda instead of pip to install the requirements. So we're installing FastAI, PyTorch, and all the requirements. Then we're going to install Flask. Flask is still in the requirements file, so we do that. Then we copy over the model. The model is stored locally, so I'm going to copy over that. Copy over the actual app.py is running the code, and set the port as 8000. So I want this application to run on port 8000. And as you can see, that's all it is. And with all the shenanigans we did on running a virtual machine, all that gets cut down to just 9 lines that we write on a Docker file to run it in a container. Now, how do we run this container, you ask? That's simple as doing. So we can just do sudo docker run and the container name. So in this case, it's deploy ML model. And that's pretty much how easy it is. And once we hit run, it's going to start running and behave just like our previous model. But instead of showing it locally, I think we can also just take a quick look at how it works on the cloud. If you want to run a container, you just go back to your Azure portal and you click on container instances. Now, we haven't gone too much into Docker in this webinar, but if you want to learn more, you can always head to the Docker website and they've got some great documentation that will tell you how to use it. Now, to create a container, you just click on add. It's very similar to how we created the virtual machine, but there are some subtle differences and we'll go into that here. Now, again, the same things. You can set a resource group, you can set a container name, you can set a region, and over here, this is important. You can set an image source. So in this case, I'm going to use Docker Hub because my image is hosted on Docker Hub. And we can give the path as, so deploy ML app is what my Docker image is called. And this will download the image directly from Docker Hub. So what this image has is it has all the dependencies pre-installed in it. So because of that, we can use a much smaller machine. And from our experimentation, you can see that something like a 1 virtual CPU and 1.5 GB machine will definitely suffice for even running this machine learning model. Another reason why you should definitely check out the cloud is you can use GPUs. So if we change the location over here, you can see that we can use GPUs as well. Some machine learning models love using GPUs, and we can set that very flexibly. A K80, P100 or V100 GPU can be set as well. And that's really cool when you want to scale up or make your model even more powerful. And once we click on create, our container is going to be created and the app will start running in a jiffy. No more setup required. How does it look like? You can see the containers right here. You can just grab our IP address. All right. And if we drop it into the search bar, you can see hello world. So hello world is our base root, as I mentioned. So because it's a slash, it just goes to hello world. But if we put the other URL, we can show that as well. And now, yes. So that was all about containers and creating the Docker file. Manikya, do you want to take us into some silicon alternatives?
Right, sure. So as we saw, CPUs and GPUs were being used in our VMs. So what if we want to use something else, something like FPGAs or ASICs? So what we can do is use Azure machine learning for deploying on these things as well. So if we go to our next slide about Azure, we can see Azure Machine Learning provides an easy way to deploy our models as an endpoint. So basically what you need to do is go to Azure Machine Learning, register your model. After that, you can select your model and directly click deploy. In this screen, which you see right here, you have to fill in the details. So one thing which is required is entry script. In the entry script, you basically have to describe what is the first thing which would run. So how to load in your model, that part. And after that, you need to specify another function, which basically tells what function will run every time your endpoint is hit. You just need to specify these two functions and you're good to go. And another file is the condas dependency file. That is like the dependencies for the environment. So that would be faster in this case. And that's all. So after this, you can basically click on deploy and your machine learning model would be deployed as a container, Kubernetes service, or a FPGA.
Awesome. So that looks pretty cool. So if you're looking to if you go to the all right. So if you're looking to a more efficient way for FPGAs or ASICs, then Azure ML is definitely the way to go. But if you want more flexibility, such as running different types of applications on maybe a CPU or a GPU, then you can look into virtual machines or containers. Now, well, that's pretty much what we had planned for you guys today. And since we've got a bit of time, I think we can just go a bit into the front end that we've written. So this front end is just a mock front end, and it's written in React. And as you can see over here, we're using Axios. If you attended Vatsal's webinar a couple of days ago, you would have learned how to use Axios. So we're using Axios to communicate from the front end to the back end. And over here, we can just drop in the URL for wherever our backend is. I've got the URL for the container that we just deployed in here already. And let's see how this front end works. Let's just give it a shot. So since this is a React, running it is a pretty simple command, just npm start. So we can do that. Npm start. And it's going to start right up. Now, if you can see here, the request that we're sending is all we're sending is a post request with the URL and to the URL with the data, which is again the URL of the image. So you can just put this exact same code into wherever you want into your website. The website doesn't have to be with React. You can put it into your mobile application and it'll work exactly the same. The data return will be the same no matter where you send this request from. Jump in here, our front end starting up. Till then, let's search for some pictures of bears. Right, so we've got some nice pictures of bears here. Maybe scroll down, find some interesting ones. All right, this is a picture of a bear in some wilderness. Okay. Maybe a picture of a bear sleeping. Yes, so we've got a picture of a bear sleeping. And very simple thing is just copy the image location. As I mentioned, use the location. Starting our React server. All right. So Manikya, you mentioned Onyx can be used for interoperability of ML models, right?
Yeah.
So in this case, we're using a PyTorch model. How hard would it be for someone who's made, let's say, a TensorFlow model to use the same method?
Right. So all they would need to do is use the functions which TensorFlow has and some, I think, more libraries provide for TensorFlow to export your model as an Onyx format. And then you can basically use this Onyx format in whichever framework you want. So this could be PyTorch, MXNet, and anything really. So that's it, I think. Yeah. Like this Onyx format can be used wherever really.
That sounds pretty cool. I think we should definitely give Onyx a shot. So you can look more into, you can research more into Onyx if you're interested. Now here we've got the mock front end that we had. Let's just drop in the picture of the bear and click submit. Now this is contacting the instance running on my container in Azure. As you can see, it tells us that you're a grizzly bear. It gives us the percentage of how much is a black bear, how much is a grizzly bear, and how much is a teddy bear. So we're 99.96% a grizzly bear. Now, Well, we're seeing a lot of grizzly bears. Can we maybe see? Let's see if we can probably see a black bear. Black bears are interesting. So black bear. So this URL can be any URL. It just has to be the image of the bear. Let's pull that up. Got a nice little black bear standing on a rock. Powerful guy. Let's see how good our model performs on him. If we head back to a front end, we can just drop in a new URL. I think I copied it. And hit submit. And once the results come, it's just loading. So as you can see, using a front end like this is a lot easier when dealing with your model, even for end users or even for third-party developers. Because when you give a URL to someone, it just adds a whole amazing face to all the work that you've done. So I'm not sure. Yeah. So now we can see the results came, and we're 98.78% sure that this is a black bear. All right. So do we have anything else to cover, Manikya? Should we try teddy bears next?
Sure. Why not?
Let's do that. So go to Bing search and hit teddy bear. All right.
If you guys have any questions, feel free to drop them in the live chat.
Yes, sure. We'd love to answer them. Oh, wow. The answer is 1. What does that mean, Manikya?
I mean, our model is basically wait. Yeah, our model is perfect, really. So you can see the value of it being a black bear and grizzly bear is very small. It's enec -9 and enec -8. So
Wow, that's pretty cool. And teddy bear, we can see it's been rounded up to 1. That's super nice. All right. So yeah, I don't see any questions coming up. I think we can try with one last picture. So if you guys may or may not know Manikya is a third-year computer science student, and he doesn't put his picture out all that often. But I, being a smart guy, have found out where one picture of Manikya does exist. And let's see whether Manikya is a teddy bear or a grizzly bear or a black bear. So what do you guys think? Drop your answer in the comments below while I hunt for Manikya's picture. So as we can see here, let's pull up Manikya's image. There we are.
okay, Srujan.
All right, copy image location. Manikya, it's time to give it a shot. What are you? Do you have any thoughts? You made this model. And once we hit click, oh wow, 70.44 for teddy bear.
All right, I think we can conclude the session on that note.
All right.
Yeah.
So
Hope you guys learned something from this. And
so thank you so much, everyone. We hope the session was really informative. We had great fun putting it together. So as we mentioned, we went through a couple of different ways of deploying, such as on a virtual machine, on a container, and on the Azure ML. Azure ML is very, very flexible, and if you want to look more into that, you can definitely go ahead. We definitely recommend looking into containers as well, since they're easy to use and small and scalable. As I mentioned before, the code for all this can be found in our GitHub repository. Let me just pop that on screen one more time. Yeah, the code can be found in the GitHub repository, and we'll also add the links for the model and the container image over here as well, if you want to try test it out. Yep.
also, don't forget to register for the quiz which Amigos is having and get a chance to win up to $1,000.
Yes, we hope you paid attention. So the quiz will be happening at 6:45 on the Amigos app, and don't miss it. All right. Right. Thank you, everyone, and have a great day.
Thank you, guys.
Thank you, guys.